G'day, how you going? So today we're looking at radians. Radians is a different way of measuring in terms of angles, but we look at radians in terms of the unit circle. Up until this point, you've been looking at degrees. So we know that a degree of a circle is equal to 360 degrees, but there's another way of calculating an angle in terms of a circle, and you've been using these kind of radians ever since you've learnt about the circle. So things such as 2 pi r and pi r squared. The pi in here is a calculation in terms of radians. So as soon as you started learning these types of formulas, you've been looking at radians. As soon as you started working with circles, you've been looking at radians. You just hadn't known about it. So what we're going to be doing today is we're going to be looking at how the radian is calculated, and then looking at a formula to help us calculate and convert from degrees to radians and back and forward. So let's get into it. So we've got a circle here, and let's look at some background in terms of radians, some terminology. We know that degrees is written as something to the power of little zero. And if we have radians, radians is usually known as C, or another way we can write it is by rads. So when we're looking at radians, we're looking at how it reflects to a circle. So for instance, if we look at this circle just here, we have a distance in terms of the radius. If we look at this here and we say, okay, we want to subject this radius to probably the same length on this curve, I could bring this up here and say, well, that's going to be equivalent to this radius. And if I connect the two lines, what I've got here is 1 radian, and hence the word radius from radian. So we have 1 radian, and what we do know is that 1 radian is equal to approximately 57.3 degrees. So what does that tell me? Well, that tells me that I could fit a second radian here. So I could fit another radian here, which is what we call 2 radians, and then I could fit a third radian. Oh, just draw that nice and neatly, which would be 3 radians. Now, what do you think would happen if I went all the way across? So if we connected this line all the way across, if I have 3 radians, I can fit 3 and a little bit of radians here. So for instance, in half a circle, I have 3 and a little bit. Let's call it 1/4 radians. Now you've seen that number before, 3.14. You know this here as pi. So therefore, when we look at this circle here, we have pi sitting here. And that's where they get that idea of using pi in circles, that it's taking 3.14 radians to give you approximately pi. So what does that tell us? Well, that tells us that if this here is 57.3, it's just under 180 degrees. So what we can say here is that pi is equal to 180 degrees. So if this equals 180 degrees, then if I do a full circle, then 2 pi is equal to 360 degrees. So, and this here equals a circle. So the idea of where radians come from is the fact that we know 1 radian is equal to 57.3 degrees, and if we can fit at least 3 and a little bit more into half a circle, And that gives us where we get our pi. So pi is equal to 180 degrees. 2 pi will be equal to 360 degrees, where these here are measured in radians, and these here are measured in degrees. And it's most common to use radians when we're working with trigonometric functions as you progress higher in your mathematics than it does with degrees. Radians has a perfect measure. We know how we get to that point, where 360 degrees, they could have come up with any value for that number itself. So, how do we convert between these two? We know that 1 pi is equal to 180 degrees, and we know 180 degrees is equal to pi. So what we can do in this instance here is, let's look at some numbers and start seeing how we can see the relationship between these points. So let's do radians and degrees. So let's start off with something that we already know. So 2 pi, 180, let's put 90 here, let's put 270, pi on 3, pi on 4, pi on 6. Alright, so let's fill in all this information. We know that 2 pi, from what we've just discovered, is equal to 360 degrees. And we also know that 180 degrees is equal to pi. Alright, so we're going to stick with this here, because this here is going to help us work out everything else in this chart. And this is going to take us to that understanding of how we use this formula to convert between radians and degrees. So if pi is equal to 180 degrees, and 90 is half 180 degrees, then I would have just half what pi is. So this here would be pi on 2. If this here is half, but I'm going one more in terms of 180 degrees, so I'm going that one revolution, so we've got half a pi, and then we've got 1.5 pi's to go. So this here would be 1 pi, half a pi, and then another half a pi. This here becomes 3 pi on 2, where we've got 3 halves, which is the same as 1.5. And we've used this kind of connection here. So we can do the same thing here. If we had pi on 3, and we know that pi equals 180, all I need to do is divide 180 by 3, and I get 60. Same thing that comes with this one. Again, pi equals 180, so therefore I can do 180 divided by 4, and 45. And then 180 divided by 6 is 30 degrees. So if we look at this a little bit further, if I had pi on 180, what would that be in terms of degrees? Well, I've got 180 divided by 180, I've got that 1 degree. And if I had that vice versa, I could work out what's going to happen. So if I then had 1 radian, well, 1 radian is going to give me 57.3 degrees from what we worked on here. So we've seen in this instance here that we've got a platform that we can use to help us go between degrees and radians. So if we look at this in instance over here, let's have a look at this conversion. And we have a table.